So this will be our example 2 for superposition theorem. So take note, the superposition theorem is very effective in your AC analysis, but not so much in your DC analysis. But this will give you the concept on how you will perform this. So we have positive 20 volts independent voltage source, and then a 2 ohm resistor, and then we have our 3 ohm resistor, 3 ohm resistor, and then a 1 ohm resistor in parallel with a current source, 2 ampere, and then we have our 4 ohms in series with a 16 volt source. So find for the value of your I and the power at 3 ohms. So how will we do this? So find for I and B is power at 3 ohms. So how will we do this? By superposition. So using superposition, let us consider our 20 ohm voltage source. So using our 20 volts voltage source, using our 20 volts voltage source, so we have equivalent circuits, which is positive, negative 20 volts, and then another 2 ohm resistor, and then a 3 ohm resistor, and a current I, and also our 1 ohm resistor in parallel with a 2 ampere current source, which will be open. Take note, open yan at superposition theorem kasi may 0 yung current nya, and then a shorted 16 volt source. Short natin yung 16 volt source natin. So this is a 4 ohm resistor. Then so shorted yung positive and negative 16 volt source natin. Okay, so colorful yung circuit in order for you to visualize the concept that I am dictating to. So since we have this circuit, I may analyze this as your 4 ohm is in parallel with the combination of your 1 ohm resistance and your 3 ohm resistance, and their combination will be further in series with 2 ohms. Another calculation of this is by basic calculation, wherein you would get the equivalent circuit and then you will get the value of I. So for faster calculation is that you will have a nodal analysis. So let's get the nodal analysis at point A. Okay, baliktad siya. So naka-invert. So this will be our A. So since we have our nodal analysis at this positive negative Vx, let's say this should be my positive negative Vx or my VA. So VA. So that will be my VA. So therefore, I will have my current direction. This should be my I 20 to node A, I20A, and then my A4 from A to 4, and then we have our A13, A13 from IA to resistance 13. Okay, so analyzing this, so KCL at node A. So we will have a value equal to IAI 20A going into the node minus IA 13 going out the node minus IA4 going out the node equals 0, which means it is your law of conservation of charges. Okay, so after that we'll find for our I20A, which is basically equal to 20 minus VA all over our positive 2 ohm, and our IA13 is just equal to VA divided by 4 ohms, and then our IA4 is just equal to VA over 4 ohms. So paano naging 4 yan? So VA divided by 1 plus 3. Okay, so let us substitute the equations. So we have 20 minus VA all over 2 minus VA all over 4 minus VA all over 4 equals 0. Okay, solving for the value of VA, so we have 10, 20 divided by 2 is 10, minus VA over 2 minus VA over 4 minus VA over 4 equals 0, which means that it is equal to 10 minus 1 half plus 1/4 plus 1/4 is equal to our VA. So therefore our VA is equal to 1, which is equal to 10. So pag transpose natin to, magiging positive VA siya, tama? So we have VA is equal to 10. So since you all know that your VA is equal to 10, therefore how will we solve for I? So paano natin solve yung I natin? Take note that I is equal to IA13, which means that it is equal to VA divided by 1 plus 3, which is equal to VA over 4. It is the value of your I, wherein your I is equal to, take note that our VA is equal to 10 volts divided by 4, therefore our I is equal to 2.5 ampere. Take note that this I is I at 20 volts. I at 20 volts, ilalagay natin I at 20 volts is equal to 2.5 ampere. Okay, so this will be our IA20. Next, at negative 16, at 16 volt voltage source. So at 16 volt voltage source, 16 volt voltage source. So what will be our circuit diagram? So take note, yung 20 volts natin masya-short siya. So masya-short siya. And then we will have our 2 ohm resistance. 2 ohm resistance. Another 3 ohm resistance. And then your 1 ohm resistance. And then an open current source. So magiging open to. And then a 4 ohm resistance. 4 ohm resistance. Okay, and then your negative and positive 16 volt source. Okay, so this will be our circuit. So how will we do this? Okay, like patulad ng dali, gagawin natin siya ng nodal analysis. But actually you can use your basic analysis like your VDT and your current voltage VDT, which is your voltage division theorem and your CDT, which is your current division theorem. Okay, but actually I prefer to use your nodal analysis or mesh analysis for simple or more simpler manipulation of equation. So let's say this will be our node A. Okay, so we have our currents. So since meron ka ng current dito, this is basically your I or IA13, IA13, and then my IA2, and then another current going to the node which is your I16A. Okay, so KCL at node A, we have a I16A going into the node minus IA2 going out the node minus IA3 going out the node, A13 going out the node, which is equal to 0. But what is our I16A? Take note that our I16A is equal to negative 16 minus VA all over 4. And our IA2 is equal to, or IA2 is equal to VA, or IA2 is equal to VA all over 2, and our IA13 is just equal to VA all over 1 plus 3, or VA all over 4. Right? So focusing on the circuit, so we'll have a value equal to IA1 16, so negative 16 minus VA all over 4 minus our IA2, which is equal to VA all over 2, minus our IA13, which is VA all over 4, which is equal to 0. So we'll have negative 16 divided by 4 is equal to negative 4, so minus VA, so plus 1/4 plus 1/2 plus 1/4 equals 0. So therefore we have negative 4 minus VA multiplied by 1, which is equal to 0. Therefore our VA is equal to, or VA is equal to negative 4. VA is equal to negative 4. So the value of our IA13, which is equal to your I at negative 16 volts, which is equal to negative 4, which is equal to VA all over our R13, which is basically equal to VA all over 1 plus 3, which is equal to negative 4 divided by 4. Therefore it is equal to negative 1. So therefore our IA at 16 volts is equal to negative 1. Right? Next is our circuit our 2 amperes, or the current IA with the contribution of our 2 amperes. So at 2 amperes tayo, at 2 amperes. So what will be our circuit diagram? So take note that your 20 volts will be shorted and also your 16 volts will be shorted. So this will be the diagram. So we have 2 ohm, and then your 1 ohm, and then we have your 2 ampere, and then your 3 ampere, 3 ohm. So lakihan natin ng konti, no, para mas mapansin. So we have our 2 ohm, and then another 1 ohm, and then your 2 ampere current source going down, and then our I, which is, we have our 3 ohm, and then another 4 ohm. Okay. Notice that if this will be the case, and I would choose this node as my ground, okay, pag yan yung naging ground ko, you will see that we will have an circuit diagram wherein your 3 ohm and 2 ohm is in series with each other, and then the combination is in parallel with your 4 ohm, right? Okay, or notice that, so wag po natin lagyan ng ground. So take note that this is a one node, isang node lang yan, and then pag wala pa tayong dinagay na ground, wag muna tayong tinglagyan ng ground para mas mapadali yung nating analysis natin. And this is just one node, and this is another node. Notice that your 4 is in parallel with 2. Tama? So therefore, since it is in parallel with 2 ohms, so I may say that it can be written into this circuit diagram. So we have the parallel combination of 4 ohms and 2 ohms is, let's say, R2 in parallel with 4 is equal to 2 in parallel with 4, it is equal to 1 all over 2 raised to negative 1 plus 4 raised to negative 1, it is equal to 4/3. Okay, so therefore I may rewrite this one as 4/3, and then my 3 ohm resistor, okay, and then another 1 ohm resistor, and my 2 ampere current source. Notice that you can readily apply your CDT, or your current division theorem. Okay, of course we will put a ground here. Okay, knowing that that would be your ground, you can see that your 4/3 and your 3 ohm resistor are in series. So 4/3 in series with 3 is equal to 4/3 plus 3 is equal to 13/3 ohms. So mapapansin mo, this is equal to 13/3 ohms. 13/3 ohms. Okay, so after that we will use your CDT, or to make sure, or para mas sure, gawa tayo ng nodal analysis ulit. So this will be our nodal analysis. So take note that this is our IA, and then babalik ta rin natin. So this is my I 13/3, which means the series combination of your 4/3 and your 3. So I 13/3, and then this will be my I2, and this will be my I1. Okay, after identifying the direction of your current, let us have a nodal or KCL at node A. KCL node A. Since you will have a KCL at node A, what are the currents entering to your node A? So we have nothing. Lahat going out sila. So negative lahat yan. I negative I 13/3 minus R1 minus 2, which is equal to 0, which means that it is with the conservation of electrical charge. So what is the value of your I 13 over 3? Basically it is just equal to VA all over 13 over 3, or for further simplification just equal to 3 over 13 VA. And then your I1 is basically equal to VA divided by 1, which is your IT is equal to 2 ampere. Okay, substituting the values, we already have our I13, which is equal to 3 over 13 VA. So 3 over 13 VA negative minus VA all over 1 minus 2 equals 0. So we have VA minus VA is equal to negative 16 over 13 VA, which is equal to, transposing your negative 2 will have a positive 2, therefore our VA is just equal to 2 divided by negative 16 over 13, which is equal to 2 divided by 16 over 13, it is equal to 1.625 VA. So take note that it is negative 1.625 VA. Volts. That is your VA. Okay, solving for I13 over 3, we have VA divided by 13 over 3, which is equal to negative 1.625 divided by 13 over 3, we have a value equal to alpha A divided by 13 over 3, so we have negative 0.375 ampere. That is the value of our I 13 over 3. But take note that our I here, our I is just equal to our I 3 at 3 ohms is equal to the negative of I 13 over 3, right? So therefore my I3 is equal to negative multiplied by the value of my I13 over 3, which is equal to negative 0.375. so therefore we will have our I3 equal to positive 0.375. Okay, I will name this I3 as I at 2 ampere, which is equal to 0.375. So how will we solve for the total current I? So solving for our I, we have I total is equal to our I at 3 ohms. So we have I at 20 volts plus I at 16 volts plus I at 2 amperes. So they have our I at 20 ohms is equal to 20 volts is equal to 2.5, and our I at 16 volts is negative 1. So we have 2.5 plus negative 1 plus positive 0.375. So we have a value equal to 2.5 minus 1 plus 0.375, we have 1.875 ampere. That is our I at 3 ohms. So what is the power? So take note that the power is equal to I squared R. So we have R is equal to 3 ohms. So we have I squared, which is 1.875 squared multiplied by 3, which is equal to 1.875 squared multiplied by 3 is equal to 10.546.875 watts. So in your quizzes, I would like you to round it in the nearest 10.55 watts. Okay, 10.55 watts. That is the solution. Okay.